These are the 3.5 notes, and they are on quadratic inequalities. So for our first example, I've got a quadratic inequality here. This is saying x squared minus 4x minus 12 is less than or equal to 0. What this is asking me is, when is this function less than 0? What x values of this function give me y values which are less than 0? So what I'm going to go ahead and do here is I'm going to graph my function. X squared minus 4x minus 12. So first thing I want to do is figure out my vertex, so I need my axis of symmetry. Negative b over 2a, which in our case is positive 4, over 2 times 1, which means that my axis of symmetry falls at x is equal to 2. I will find f of 2 for my y value of my vertex. So I've got 4 minus 8 minus 12. It's negative 16, so I've got a point 2, negative 16. I'll factor and find my x-intercepts. So I've got x minus 6 times x plus 2 as my factors here. So x minus 6 is equal to 0, x plus 2 is equal to 0. X is equal to 6 and x is equal to negative 2 for my x-intercepts. This matches up well considering my axis of symmetry. When I graph this, I'll count my y's by 2's, so that way I can fit it on my y-axis. And I'm going to count my x's still by 1's, so I've got 2, negative 16, x-intercept at negative 2, x-intercept at positive 6. And I'm going to graph my parabola. Now that I'm here, I'm looking for my values of this function where x is less than or equal to 0. This area is where my function is less than or equal to 0. It is the area which this entire graph exists under the x-axis. I'm asking where my y value is less than 0. My highlighted area is where my y values are less than 0. It lies below the x-axis. That's 0. So here, this means that between my x-intercepts is where it is less than 0. I could say it like this. I could also say it like this. X is greater than negative 2. X is less than or equal to 6. Both of those are correct answers. Either or is the correct answer there. You're just telling me that it's between negative 2 and 6. In some way, shape, or form. There is no shading in this. This is not a shading-based inequality. I know we are so tempted to do shading because you've been doing shading for all of your inequalities, from the ones that you've done on a number line to the ones that you have done as linear equations. There is no shading here. This is legitimately just asking what x values give us y values less than 0, and it's very specific to this equation. We are looking at one specific quadratic function, and we are trying to figure out solutions to this quadratic function which make it less than or equal to 0, and that's it. Another thing we could have done here, and this is something that I'll say, some students need to graph this entire thing, which is okay. You could have also found your x-intercepts, realized that this is concave up, and since it is concave up, it will be less than 0 between those x-intercepts. You can do this with these types of functions. You can just use the information of if you have a positive or negative parabola, if it is opening up or down, and your x-intercepts with these types of inequalities. If this does not make sense to you, what I just said, I highly encourage you to graph them. Graphing these always works for you. I still graph them in my answer keys. I graph them as all my solutions. I could do this by just finding my x-intercept and using the information on concave up and concave down, but that is something that I'm not going to, by any shape or means, require you to know. I think that graphing these, A, helps you practice graphing quadratics, B, helps you understand what you're actually looking for a little bit better, and sometimes you need the visualization of what is actually greater than or less than. All right, example 2, this is still a quadratic inequality. 2x squared is less than x plus 10. First thing I want to do is move everything to one side. 2x squared minus x minus 10 is less than 0. So I'm going to be going for the same thing here. I'm going to be trying to figure out where my entire quadratic is less than 0. I'll find my axis of symmetry. Positive 1 over 2 times 2. This is occurring at 1/4. I'll find my y value of my vertex by f of 1/4. So that's 2 times 1/16 minus 1/4 minus 10. This is the 16th, so that's 1/8 minus 1/4 minus 10. 1/8 minus 2/8 minus 80/8. So this will be negative 81/8. So this is just a little bit greater than negative 10. So again, I'll count my y-axis by 2. I'm going to count my x-axis this time, though, by 1/8. So let me shrink all my work. So I'm going to go ahead and at 1/4, negative 81/8, which would just be a little bit past 5. 1, 2, 3, 4, 5. So this would be where my vertex is based on the scaling of this graph. I'm counting my x's by 1/8 and my y's by 2's. Next thing I need to do is try to figure out where my x-intercepts are. So here, let me factor this. My a times c value is negative 20. So I'm looking for numbers that multiply to negative 20 but add to negative 1. That's positive 4 and negative 5. So I've got 2x squared plus 4x minus 5x minus 10. Factor by grouping. I've got 2x times x plus 2 minus 5 times x plus 2. So x plus 2 times 2x minus 5, x is equal to negative 2, x is equal to 5. Halves are my 2 x-intercepts here. I go through. Negative 2 would fall, and let's actually not count my x's by 1/8 because that's not going to fit. I should have found my x-intercepts first. That's okay. I'll count my x by 1/4. So in that case, I should move my vertex over to there for my 1/4, but negative 2 will fall right here. This is negative 2 by a 1/4 scaling. This is 5/2 by a 1/4 scaling. And I'll go ahead and draw my parabola through these points. This is my parabola. Again, I'm asking where is it less than 0. It's less than 0 between these x-intercepts. So that means from negative 2 until 5/2 would be my answer. This answer is in parentheses because it is just less than, not less than or equal to. I could also say x is greater than negative 2 or x is less than 5/2. Again, I'm just looking for x values which make my y value less than 0. I'm not concerned about shading or anything. I just want to know where does this parabola lie below the x-axis once I've moved it. Now, you might be asking, this is different than the original question. This is not 2x squared less than x plus 10. This is 2x squared less than 2x squared minus x minus 10 less than 0. Well, there's a second method, for example, too. I'm not the world's biggest fan of this because you're still going to end up doing a lot of the same work that you would have done prior, but the book does show it to you. I feel obligated to show it to you. Maybe this will make more sense to you. So we want to figure out, solve the inequality 2x squared is less than x plus 10. I could graph these as two separate things. I could say I've got f of x is equal to 2x squared, and then I've got like g of x equal to x plus 10. So I could go through. I'm going to count my y values by 2 again to make sure this actually fits. 2x squared is a quadratic with one simple transformation. So that means I multiply by 2. So when x is equal to 1, y would be equal to 2. When x is equal to 2, y would be equal to 8. When x is equal to 3, y would be equal to 19. And we could draw a parabola through here. G of x would be equal to x plus 10 with our case of our x values counting by 1 and our y values counting by 2. So 3, 4, 5. This would be where our y-intercept is. And then up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. I can now draw my line x plus 10. I use my y-intercept and my slope to draw that line. Y is equal to x plus 10. So here, again, I'm looking for these x values. When I'm saying 2x squared is less than x plus 10, I'm asking where are the x values, or where are the y values of this parabola less than the y values of this line. The area that I've just highlighted is where those y values are less than the y values of the line. Between these two x values is where it is. Well, I can't just eyeball this graph and figure out what those x values are. I'm actually going to go through the process of solving this. So I would have to figure out, okay, where do they intersect? Because this is going to give me the information I need to figure it out. So if I set 2x squared is equal to x plus 10, I'm going to go through the exact same process. I'll get that 2x squared minus x minus 10 equal to 0, and then I'll factor and solve. We've already factored and solved this. You have 2x minus 5 times x plus 2. So when you set and solve for your zeros here, you end up with x is equal to negative 2 and x is equal to 2/5. And it would exist. It would be less than this value between negative 2 and not 2/5. This is 5/2. I apologize. That's backwards. And 5/2. We could also think about this as the fact that it's negative 2 and 2.5. If decimals is a little bit easier for you to think, we look here. Obviously, the graph is intersecting at negative 2 right there. We have that point that exists. It's not drawn as well on my part because I'm not the world's best, but we can kind of see here where x is equal to 2.5, right around there where x is equal to 2.5, those graphs are intersecting again. So exact same answer as the first time I did it, and that's how it should be. You shouldn't get different answers with the same inequality. It's just a different matter of how I approached it. I tend to think the first method I did was easier. Just set it up as a quadratic in relation to 0, and look at where it exists in comparison to the quadratic. You're going to have to do all the same amount of work for example 2 anyway. It's not like one method saves you work versus the other. I just think it's a little bit harder to think about where is this parabola greater than or less than the line versus where is this parabola greater than or less than the x-axis. The x-axis is a lot easier to see. You're just using your x-intercepts. You can draw your vertex. You can draw your full parabola. Makes a lot more sense to me, especially when in this case, it was a little bit easier where our parabola had a vertex at 0, 0, and it was just a basic transformation. When you start getting into other parabolas compared to other lines, it gets a little bit tougher. So this was one of the easier ways to do this. If you're ever comparing a parabola to a line, my best advice is do the first method. That's how I do every single one of my problems. However, if you like this better, if this makes more sense, if graphing the line and the parabola and then looking for those intersection points helps you visualize this a little bit better, do that. Now, first year I taught this, the book does not include this. But the first year I taught this, so many students were getting confused and they wanted to shade things so often. So last year what I did was I included inequalities where you actually shade and had students practice that as well. And the improvement of knowing what you're doing with what inequality went through the roof. Students stopped shading the x inequalities nearly as often. And when you know what you're supposed to shade versus what you're not supposed to shade, that debate becomes less so because you have standard rules to go by. I'm giving you inequalities right here that have to be shaded. So I've got y is greater than x squared minus 81. This is a really, really quick quadratic to draw. First of all, it's just a transformation shifted down 81 units. Also, I can go ahead and factor this x squared, or this is x minus 9 times x plus 9. So I've got 9, 0, and negative 9, 0 as my x-intercepts. I'm going to count my y-axis by 9s just to make life easier. So that means this is where my vertex would be at 0, negative 81. I'm going to keep counting my x-axis by 1, so I would have these two x-intercepts at negative 9, 0 and 9, 0. I'll draw my parabola through them. Now this is asking where y is greater. I'm not asking about a number in relation to my entire function. I'm asking about all y's compared to this function. Since I'm asking about all y's compared to this function, this is where I would actually shade things. And I would say, okay, any y that lies above this parabola is greater than. Now I shouldn't just do this, I just remembered this as I started shading. What I should do is I should choose some points to plug in. So like, let's say, let's look at this point 0, 0. We're gonna make this a test point. I need to know both my x and y value here. So I'm gonna plug in, okay, if the point 0, 0, x squared minus 81 checks out. So I'm saying if x is 0, y is also 0, 0 is greater than negative 81, this checks out. So this point 0, 0 is a point which is greater than this parabola. Now let's choose another point. I'm going to go with the point 0, negative 90. So now I'm looking at negative 90 is greater than 0 squared minus 81. Negative 90 greater than negative 81. This is not true. This does not work out, so I don't shade below there. Those y values are not greater than this parabola or not greater than this function. Last thing is, since this is just a greater than, I should have a dashed line here. This is just a greater than. It is not a greater than or equal to. So I'm just going to have a dashed line for my parabola. So this is where you actually shade your inequality. I'm using the test points. This is something you learned in Algebra 1, something you practice again with inequalities in Algebra 2. You've got to go through, you've got to test your points, you've got to realize where it is a true statement versus where it's not a true statement. I found out the point 0, 0 is a true statement. The point 0, negative 90 was not a true statement. So I'm going to shade the area of the parabola where that true statement was, which is above the parabola in this case, inside the parabola if you want to think about it that way. Choose points with zeros as much as you can. If you can get a point 0, 0 that's clearly part of your parabola or not part of your parabola, use it. Always work with zeros as much as you can. When you have the freedom of choosing a test point, choose smart test points like 0, 0, 0, negative 90, things that are clearly on one side of a parabola versus another, but easily defined by 0. All right, solve and graph this quadratic inequality. So I've got y is greater than negative x squared minus 4x plus 5. So here, this one's a little bit tougher to graph. I actually have to go through and figure out my axis of symmetry again. So axis of symmetry is positive 4 over 2 times negative 1 because it's negative b over 2a. So I end up with negative 2 for my x value. I'll find f of negative 2, which is equal to negative 2 squared minus 4 times negative 2 plus 5. This is negative 4 plus 8 plus 5. This is 9. So I've got a point negative 2, 9. I'll count this by ones everywhere. All right, now let's go ahead and figure out our x-intercepts for this graph. So I've got an a times c value of negative 5. So I need numbers that multiply to make negative 5 but add the negative 4. So this is going to be negative x squared plus x minus 5x plus 5, because negative 5 times 1 is negative 5. Negative 5 plus 1 is 4. This is just factoring by grouping and practicing those rules. In this case, I can take out a x and get negative x plus 1. Over here, I can take out a 5 and get negative x plus 1. So now I've got x plus 5 times negative x plus 1 as my factors. X plus 5 equals 0. X is equal to negative 5. Negative x plus 1 is equal to 0. Negative x is equal to negative 1. X is equal to 1. So my two x-intercepts here are negative 5, 0, and 1, 0. This makes sense given the fact that my vertex is at negative 2. So negative 5, positive 1. I can draw my parabola here. This is also just greater than. So when I draw this parabola, I need to make sure I'm actually plugging in it as a dashed line. If it were greater than or equal to, that's where it would be a solid line, because I'm saying that it's included in my answer. So I've got my dashed parabola. All right, I've got two easy points that I can check for here. I can check the point 0, 0, and I can also check the point 0, 10. And this will give me a good idea of where I need to shade. So let's test. All right, 0, 0. If y is 0, is this greater than negative 0 squared minus 4 times 0 plus 5? I plug this in. 0 greater than 5. This does not check out. All right, now let's test 0, 10. I plug in 10. 10 is greater than negative 0 squared minus 4 times 0 plus 5. 10 is greater than 5. This checks out. So when I'm shading this graph, I'm going to shade outside of my parabola, because these are the y values which are greater than the parabola. It's everything which is on the outside of it. And that is how I would go about doing that. I found my test points, I used my test points, and I shaded based off where y is greater in comparison to the parabola. All right, homework's a little bit long tonight. You have both book work and a worksheet to do. The worksheet is all based on shading. Everything in the book is just going to be comparing a function to a either linear equation or a specific numerical value. Again, I highly encourage you put everything in terms of 0. If you have any questions or concerns, please reach out and have a great night.